This question is an example of implicit differentiation. The first thing to notice is the phrase implicit differentiation may not appear in the question. So you have to recognize when we're not given a function y equals something, if y is mixed up in a more complicated expression, then implicit differentiation is likely to be required. A curve C is described by the equation 3x squared plus 4y squared minus 2x plus 6y minus 5 equals 0. Find an equation of the tangent to C at the point 1 minus 2, giving your answer in the form ax plus by plus c equals 0, where a, b and c are integers. Well, before we can find the equation of the tangent at the point 1 minus 2, we'll need the gradient at the point 1 minus 2, and that's where the differentiation comes in. So let's differentiate this equation with respect to x. So I differentiate 3x squared and I get 6x. Differentiate 4y squared with respect to x. We do that by differentiating it with respect to y and we get 8y, and multiply by dy by dx. So to differentiate a term in y with respect to x, we differentiate it with respect to y, multiply by dy by dx. Differentiate minus 2x with respect to x and we get minus 2. And now we come to a product function, and you need to recognize this because it often crops up in implicit differentiation. You've got to treat this as a product of 6x and y. So the differential is the first one, 6x, multiplied by the differential of the second one, and the differential of y is 1 dy by dx. Plus the second one, that's y, times the differential of the first one, 6x, and that's just 6, so that gives us 6y. Differentiate the minus 5, you get 0, equals, differentiate the 0, you get 0 again. Now we're going to collect the dy by dx's together, and we're going to have 8y plus 6x lots of dy by dx. We take all the other terms to the other side, and the minus 2 becomes 2, the 6x becomes minus 6x, and the 6y becomes minus 6y. Now here I can see a common factor of 2 running through the whole relationship, so let's divide through by 2, and we get 4y plus 3x dy by dx is equal to 1 minus 3x minus 3y. So dy by dx is equal to 1 minus 3x minus 3y divided by the bracket 4y plus 3x. So we've now got an expression for dy by dx. We want the equation of the tangent at the point 1 minus 2, so I want the gradient at 1 minus 2. And that will be equal to 1 minus 3 lots of 1 minus 3 lots of minus 2 divided by 4 lots of minus 2 plus 3 lots of 1. So that's 1 minus 3 plus 6 divided by minus 8 plus 3. 1 plus 6 is 7, take away 3 is 4, and minus 8 plus 3 is minus 5. So the gradient is minus 4/5. So we now want the equation of the tangent through 1 minus 2, which has gradient minus 4/5. Y minus y1 equals mx minus x1, where m is the gradient. So we get y minus minus 2 is equal to minus 4/5 x minus 1. So that's y plus 2 is equal to minus 4/5 x minus 1. Multiply through by the 5 and we get 5y plus 10 is equal to, and then I want the minus 4 multiplied by the x minus 1. So that'll be minus 4x plus 4. Bring everything to the left hand side. 4x plus 5y plus 10, and when the plus 4 comes across becomes minus 4. Plus 10 minus 4 is plus 6. And that will be equal to 0. And that gives us the equation of the tangent in the form required. ax plus by plus c equals 0, where a, b and c are integers. And that completes the question.